Welcome to the Math Record. Today I'll be covering the ICTM State 2015 Division A Algebra 1. I'll be going through every single question as usual from 1 to 20, and if you want to look for a specific question, I'll be linking it in the description below. Okay, number 1. The operation is defined as a function b is equal to 3a squared plus 2b. Determine the value of k such that 11 function k is equal to 2015. So then 3 times 11 squared plus 2 times k is equal to 2015. So just plug in your calculator and you'll find it. So 2015 minus 3 times 11 squared divided by 2. So k is equal to 826. Okay, starting off pretty easy. Okay, number 2. Mary can work 10 similar questions in 15 minutes. Matt can work 6 of the same questions in 15 minutes. Determine the number of minutes it would take them working together to work 2015 of these similar questions. Okay, so Mary's rate is 10 questions in 15 minutes. Matt's rate is 6 questions in 15 minutes, so their total rate is 10 over 15 plus 6 over 15. So the rate times their time should equal to how many questions they finished. So we just need to multiply by time is equal to 2015. So then to time, just using your calculator. So that's 16 over 15, and then 2015 divided by 16 over 15, which is equal to 30,225 over 16. And that should be your answer for number 2. Number 3, if 3/4 more than 3/4 of a number, so 3/4 of a number, right, and then 3/4 more than that is equal to the opposite of 3/4 of a number. So the opposite just means the negative. So then we need to determine the number. So we need to find x. So add the variables together. So that's 6 over 4x equals negative 3 over 4. So that means x has to equal to negative 1/2. So that's your answer for number 3. Basically that simple. Number 4, determine the vertex of the parabola given by y equals negative x squared minus 2x. Find the order pair kw. Okay, so there's two ways to do this. You could just use the equation, or you could just use it in vertex form. So using the equation is negative b over 2a. So then negative of negative 2 is 2. And then 2 times a, which is negative 1, is just negative 2. So that's negative 1. So then we have negative 1, plug it back to the equation. So negative 1 squared is 1, times this negative 1 is negative 1. So and then negative 2 times that negative 1 is 2. So 2 plus that negative 1 is 1. So this is your coordinate. So another way you could do it is just use the vertex. So distribute out the negative, so that's x squared plus 2x. So what's half of 2? That's 1. So this is going to be negative x plus 1 squared. So this factors out as x squared plus 2x, right? And then we have a plus 1. So we have an extra plus 1 here. So we had to take away that. We have the extra plus 1 inside, and times this negative 1 is going to be negative 1. So since we have extra negative 1, we need to add a 1 to cancel that out. So then our coordinate is going to be negative 1, 1. Right? So that is both ways to do it. So I'll just box it. Negative 1, 1. Okay. Number 5. Um, basically, these exponents equals k x to the power k, w to the power w, z to the power p, and then add those k plus w plus p. So we're just gonna work inside out. So then basically work on the numerator first. So then when you're multiplying by when it's raised to a power for exponents, you just multiply. So 2 times negative 2 is negative 4. Negative 4 times negative 2 is 8, and then this one b is negative 6. And then we do the same thing for the denominator. So that's going to be 5, that's negative 3, and that is negative 2. Okay, and these are all raised to the power of negative 2. So inside again. So then if it's negative, you go to the bottom. If it's negative, you switch places, I mean. So then this 4 goes to the bottom with the 5. So 5 plus 4 is 9. And then y equals negative 3, so it goes to the top. So that's y equals 11. And then we have z, which is negative 2. And then this one's negative 6. So this one is going to be 2 on the top and 6 on the bottom. So you're going to have a 4 on the bottom. Oh, sorry. Okay. Then raised to the power of negative 2. So this could be y equals negative 2, x equals negative 18, z equals negative 8. So you could just move it to the top as y equals negative 2, x equals 18, and z equals 8. I mean, z to the power of 8. So add them together, that's 26 minus 22, that's 4. So that is your answer for number 5. Number 6, determine the sum of the solutions for the equation 3 minus x. So I usually like to make it positive, so I'm just going to put a negative in front there. So that's that x minus 3. And then we're going to factor out the bottom, so it's x plus 3 and x minus 3. So I usually just do this because it'll save time. Usually the questions ask you to just like combine them together or solve for something. So usually you just want to factor all them out. So then this one's x plus 2 and this one's x plus 3. And this is equal to negative 2. Okay, so we could cancel this one out. And then since the bottom has to be the same, we need to multiply this one by x plus 2. Okay, so this one's negative x minus 2 and then minus a 2x squared. So this one's x plus 2, x plus 3 is equal to negative 2. So we're going to multiply the denominator by that number. So this one was x squared plus 5x plus 6 as is given in the equation, but I just factored it out. So multiplying that one by that, negative 2x squared minus 10x minus 12, right? And then we could cancel this term out and then put this term over here, so that's 9x. Negative 2, so negative 12 plus that 2 is equal to 10. I mean negative 10. So x equals negative 10 over 9. And that is your answer for number 6. Number 7. For all v values of x, so a to x plus 3, x minus 4 plus 2c is equal to 4x plus 1 squared plus kx minus, oh, that looks kind of bad, 2 plus kx minus 101. Determine the sum a plus k plus c. So we have to just find out all the coefficients and add them together. So let's work with a quadratic. So we're going to work with the quadratic term and then the linear term and then the constant. So for our quadratic, the only one that has it is 2x times this x, which is just 2x squared, right? So that's your quadratic. So your 2 times that a is your coefficient for quadratic. And on this side, it's just 4 squared, which is 16. So that gives us the a is equals 8. And that's it. Okay, now for the linear, which is 2 times this negative 4, which is negative 8. 3 times x is 3. And then we need to scale it up by a. And there's no more on this side. So then on this side, we have a 4 times a 1, which is 4 times 2, which is 8, right? Because there's 2 of them. And then plus that k, which gives us our linear. We already know what a is, so a is 8, right? So negative 8 plus 3 is negative 5. Negative 5 times 8 is negative 40. Negative 40 minus this 8 equals negative 48. So k is negative 48. Okay, now we need to find c. So the constant term is here is 3 times 4 is negative 12. So negative 12 times that a plus the 2c is equal to our constant here. So 1 squared is just 1. And the only constant here is and the other constant here is negative 101. So subtract them, that's negative 100. We already know a is 8. So then negative 12 times a, it was negative 96. So on this side, you have to add that 96. So, sorry, that's 100. So negative 100 plus that 96 equals negative 4. And then c equals negative 4 divided by 2. So c equals negative 2. So negative 48 plus negative 2 is negative 50, plus this 8 is negative 42. So that is your answer for number 7. Okay, number 8. Determine the positive difference of the solution for x over 6 minus 6 over x equals 3 over 2. Okay, so we need to get the same denominator, so this one becomes x squared minus 36 over 6x equals 3 over 2. So then we just need to cross multiply, so that's 2x squared minus 72 is equal to 18x. They're all even, so we could divide by 2, so x squared minus 36 equals 9x. So then x squared minus 9x minus 36 is equal to 0. So x minus 12 and then x plus 3. So that means this is 12, this is negative 3. So we need to find the positive difference, so it's be 12 minus a negative 3, which is 15. So that's your answer for number 8. Number 9. In a group of 100 adults, 18 have neither a Visa or MasterCard. 15 of these adults have Visa cards, and 37 has MasterCards. One adult is selected at random. The probability that this person has a Visa and a MasterCard is k%. Okay, so let's do a Venn diagram. So this is a Visa, and this one's a MasterCard. So they said 18 does not have it, so it's outside the circles. So if 18 is outside the circles, that means 82 is inside. So let's call this A, call this B, call this C. So we have A plus B plus C is equal to 82. And they say 52 has Visa cards, so Visa is A plus B. And they say 37 has MasterCards, so MasterCard is B plus C. So using the first and second equation, that means you could get that C is equal to 30. So using the first and third equation, that means you could get that A is equal to 45. So, so since we know that A plus B plus C is equal to 82, that means B, that's 75. So 82 minus 75 is 7. So we know that the middle term, which is what we need, that's Visa and MasterCard, is 7. So 7 out of the total, which is 100, is 7%. So it's just 7. So your answer for number 9 is just 7. Number 10. The equation of the the line perpendicular to line 15x plus 2y minus 10 is equal to 0 passes through the point 15, 6.5 can be written as ax plus by plus c is equal to 0. And then you just had to add a plus b plus c. Okay, so the trick with perpendicular equations is basically if you have a line and you want a line that's perpendicular to that line, basically you just had to switch the coefficients of the x and y and then make the one of those negative. Change the signs of one of them. So we're gonna fit. So then this one is gonna be 2x minus 15y, right? So you switch the 2 and the 15 and then make the 15 negative, basically. Or you could make the 2 negative and keep this one positive, and keep the 15 positive. But it doesn't really matter. It's just that one of them has to change signs. And then plus c is equal to 0. So we have to find plus c. So now we know it goes to the point 15, 6.5. So just plug it in. So that's using our calculator, we get that 2 times 15 minus 15 times 6.5 is equal to negative 67.5 plus c is equal to 0. So c equals 67.5. So it's 2x minus 15y plus 67.5 equals 0. So since you want integers, just scale up by 2. So 4x minus 30y plus, and then multiply by 2, plus 135 equals 0. So 135 minus 30 equals 105. 105 plus 4 equals 109. So that is your answer for number 10. Okay, first 10 questions should be pretty simple. Number 11. Determine the smallest possible integer that gives the same non-zero remainder when divided by each of the elements from the set 2, 3, 4, 5, 6, 7, 8, 9. Okay, since they never required any restrictions, the smallest one is always going to be 1. If they're just given integers, right? Whole numbers or natural numbers basically, then it's always just going to be 1 because 1 divided by any number higher than itself is basically just remainder 1, right? Because 1 divided by 2 is 1. 1 divided by 3 is 1. 1 divided by 4 is 1. 1 divided by 3 billion is 1. It's always going to have the same remainder. So this is going to be true. Okay. So the answer for number 11 is just 1. If there is no restriction and say it cannot be 1, then the answer is just gonna be just the LCM plus 1. So let's go through every single number. So 2, 3, 4, 5, 6, 7, 8, 9. So it'll be 2, 3, 4 is just 2 times 2, so we already have a 2, so put another 2. We need a 5. 6 is just 3 times 2, we already have it. 7 we need. 8 equals 2 times 2 times 2, so we only had 2 of them, so we need one more. And then 9 equals 3 times 3, so we need a 3. Okay, so now we have all these numbers, and you can just multiply them together. So 2 times 3 times 2 times 5 times 7 times 2 times 3, which is 2520, right? And then whatever this number is, you could just add 1 equals 2521. Okay. So if they say what is the smallest one and they never restrict it, it's always going to be 1. And then if it's like the specific case, then the next one is 2521, which gives another same remainder. And the next one is going to be multiply this one by 2. So it's going to be times 2 plus 1 equals 5041. And the next one is just 3 times that number plus 1. And then the fourth number is 4 times this number plus 1, right? So you just gotta keep multiplying because this is gonna be the LCM. So the LCM divided by whatever the number is always gonna be integer. So then plus that 1, which is your remainder, it's always just gotta get that remainder. So it's always gotta be that remainder. And that's how you basically do the math. But the answer for this question is just 1. I'm just showing you how to do it if it's not 1. 12. All, all ages are whole numbers of years. Tom, Dick, and Henry equals 91. Ha Harry is 1 year younger than Tom and Dick's age combined. So Harry equals Tom plus Dick's age minus 1. And Dick's age is 1 year more than 2 times Tom age. Okay, plus 1. Okay, so we need to find H because we need to find Harry. So we'll just plug everything in for what we have. So T plus our D is 2T plus 1. And then our H is equal to T plus D. So we already have D, which is 2T plus 1. And then minus a 1 from here again equals 91. So this and this cancel each other out. So then 2, 4, 5, 6. So we have 6T plus 1 equals 91. So so T equals 91 minus 1 equals 90. 90 divided by 6 is 15. So we have T equals 15. So we could plug it back into this equation to get our D. So that's 30, 31. And now we could plug both of these back in to get our H. So 15 plus 31 equals 46. 46 minus 1 is 45. So Harry's age is 45. So that's your answer for 12. Okay, 13. Determine the sum of the roots for the equation ax squared plus 5x minus 63 equals x plus 49. Okay, so let's make it a quadratic. So 8x squared plus 4x minus 112 equals 0. So then the trick to this is that you take the coefficient of the of the second highest term, which is 4, and then you divide by the coefficient of the highest term, which is 8. And then you put a negative in front. And that should be the sum of the roots. So that's negative 1 half. Okay, so your answer for number 13 is negative 1 half. And the reason is because let's say our roots are a and b, so x minus a, x minus b, and then we have a coefficient of k, right? So then if you expand this out, it's going to be kx squared minus ka plus b x, and then plus kab, right? You want a plus b because that's the sum of your roots. So that's why we have, so your second coefficient is negative k over a plus b, and your first coefficient is k. So then when you divide each other out, you cancel out the k. And that's why we need another negative in here to cancel out this negative, so we just get a plus b. And that's why this works. But the answer, yeah, so the answer for number 13 is negative 1 half. Number 14, 2 minus square root 3 over 2 plus square root 3 plus k squared w equals 2 plus square root 3 equals 2 minus square root 3. So find k plus w. Okay, so we have k square root w. Just subtract the number to the other side. So then we have a minus 2 square root 3 and 2 plus square root 3. Okay, so we just need to multiply this equation by 2 plus square root 3 and multiply this equation by 2 minus square root 3 on the top and bottom, right? Because that's the complex conjugate. So we already know this is k squared root w. So then 2 times 2 is 4. Square root 3 times square root 3 is 3. And then 2 times square root 3, 2 times square root 3, that's 4 square root 3. Add up together. Okay, now on the bottom, 2 times 2 is 4. 2 negative square root 3, 2 square root 3, those cancel each other out. And then negative square root 3 times square root 3 is minus 3. Minus. Now we do the same thing here. 2 times 2 is 4. Negative square root times square root 3 is 3. 2 times negative square root 3, 2 times negative square root 3 is just negative 4 square root 3. Okay, so this one's 4. Negative square root 3 times square root 3 is negative 3. Right? Because 2 square root 3 and 2 negative square root 3 cancel each other out. So 4 minus 3 is 1. 4 minus 3 is 1. So anything divided by 1 is just itself, so we could just ignore it. So this is 7 plus 4 square root 3 minus this number, which is 7 minus 4 square root 3. So the 7 cancel each other out, and then negative of negative 4 square root 3 plus this 4 square root 3 is 8 square root 3. So that is our k and w. Add them together, that's 11. So our answer for number 14 is 11. Okay. Number 15. Xavier and Evie starts at noon at 60 kilometers apart on a trail. Okay. So this one is 60 kilometers apart. And they drive directly toward each other. So let's say this one's Xavier and this one is Evie, right? So if Xavier's speed was 4 kilometers per hour greater than Evie's speed, so let's say Evie's speed is A, That means Xavier's speed is a plus 4. And they took 1 hour and 30 minutes. Yeah, so it's 1.5 hours, right? Because noon is at 12 o'clock, and they meet at 1 hour and 30 minutes. So that's 1 hour, 1.5 hours past. So so we're gonna be keeping track of his position. So let's say Xavier starts at 0, right? And Evie starts at 60, right? So they're 60 distance apart. So if it starts at 0, then his speed, right, his rate, which is a plus 4, times his time, which is 1.5, plus his initial position, which is plus 0, so it does nothing, is equal to where Evie is going to be at that time, which is 1.5 times her speed, which is a, right? But she's going backwards, so you got to put a negative in here, plus um, where she started from, which is 60. Okay, so this is sorry, this is 1.5a plus a 6 is equal to negative 1.5a plus 60. So this is going to be equal to 3a. This is going to be 54. That means a equals 18. So the question asks, determine Xavier's speed. So Xavier's speed is a plus 4. So 18 plus 4 is equal to 22. So that is your answer for number 15. Number 16. Determine the positive integer x is the product of 5 times k times w, right? Product of 5 w and k and w. If k is a two-digit integer such that the tens digit is 2 more than the ones digit, okay. So k is a two-digit integer, so that's a tens digit. So its 10 digit is 2 more than the digit of its unit, so a plus 2 plus a. So if your unit's digit is a, then its 10 digit is a plus 2. Now we do the same thing for w, right? So w is a two-digit integer whose tens digit is the same as the unit digit of k, and whose unit digit of k is the same as the 10 digits. So they just switched each other around. So this one 10, so you put the a in here, and then for this one you put a plus 2. So this one distributes out as 11a plus 20. Distributes out as 11a plus 2. Okay, so determine the value of x when w is as small as possible. So w is as small as possible as a two-digit integer. A has to be equal to 1. So that's equal to 13. And then k would be, put a 1 here, so that's 31. And then we times the 5 to get our x. So using your calculator, 13 times 31 times 5 is 2015. And that is your answer for number 16. Okay, number 17. Determine the value of the expression a plus b over b minus c. So where a equals 6, b equals negative 2, and c equals negative 3. Right, so you just plug it in. So we have a 6 minus a 2 over a negative 2 minus a negative 3, so plus 3. So that's a 1, so that's 4, so this comes out as 4. So that's your answer for number 17. Basically that simple. Okay, number 18. When x cubed minus 7x squared plus 4x plus k is divided by x minus 2, the remainder is 15. Determine the exact value of k. So what you have to do is use something called the remainder theorem. So if you have a polynomial, let's call that px, and it's divided by something like x minus a, then the remainder is always going to be pa. That's basically the theorem, all it is. Okay, plus k. So if we put a 2 in here, that's 2 to the power 3 minus 7 times 2 to the power 2 plus 4 times 2 plus k, that should be equal to 15. So that is 8 minus 28 plus 8 plus k is equal to 15. So that's 16, so that's negative 12 plus k equals 15, so k equals 27. Oops. So your answer for number 18 is 27. Okay, 19. Determine all values for x such that the square root of 3x minus 5 minus 2 is equal to 5. So we add 2 to both sides, so then we get equals 7. So square both sides, so 3x minus 5 equals 49. Add 5 to both sides, sorry about that, equals 54. So divide by 3, we get 18. So your answer is 18. Another thing you should do probably is to check it. So plug in 18 back in, so that's 54 minus 5 is 49 squared, 49 is 7, 7 minus 2 is 5. So that works. But sometimes it might be negative, it might not work. So look for extraneous if extraneous solutions if you ever see any. So, but 19 is definitely the answer is 18. 20. Determine the sum of all integral solutions for the equation absolute value of 2x minus 8 is less than 12. So basically just telling you that the 2x minus 8 is between negative 2x minus 8 has to be less than negative 12, and 2x minus 8 has to be less, sorry, has to be greater than negative 12, and 2x minus 8 has to be less than 12, right? So then this be negative 20, so x has to be greater than has to be greater than negative 10, right? And then we have where our 2x is less than 20, and x has to be less than our 10. Oh, sorry, this is, oops, let me rewrite that. Cannot add. Negative 12 plus 8 equals negative 4, so this one x is greater than negative 2. Sorry about that. And then 20, x is less than 10. Okay, so then, so if x has to be greater than negative 2, that means all the integers has to be from negative 1, and then 0, 1, 2, 3, and it has to be less than 10, so let's go up to 9, to 4, 5, 6, 7, 8, 9. Right, so 0 is nothing. 1 cancel out this 1, so we just have 2, 3, 4, 5, 6, 7, 8, 9. Right, so 2 and 9 makes 11. 3 and 8 makes 11, 4 and 7 makes 11, and 5 and 6 makes 11. So we have 1, 2, 3, 4. So we have 4 of them. So 4 times 11 equals 44. And that is your answer for 20. And that basically covers everything for this year. So what you need to know is just like basic uh, algebra, like functions, like square roots, and like absolute values in inequalities equations. Then there's some like kind of precalculus concepts like remainders that you want to know. 17 is simple, you should get that right. 16 is just a word, but it's not really that difficult. 15 is like a word question of equation. 14 is a complex number, so it's kind of like precalculus. More polynomials. Uh, they might have an age question. It doesn't occur every year, but it occurs often enough that you might want to like understand how they word like their sentences. Like when they say Harry is 1 year younger than Dick and Tom's age combined. So you want to understand what does that mean in equation form. Know like some tricks like that perpendicular equation trick. But you could if you have time you could finish it pretty easily. Venn diagrams, more equations, more polynomials, more equations. No exponents and radicals, basically. Equations, word form. No rates, basically. And then there's just really easy question. Usually when they give like a function like this, it's usually really easy since you're giving your calculator. And that's basically everything for this year. Okay, well, thanks for watching, and I'll see you at the next math record.